Hey everybody, so today I'm gonna talk about water diffraction. So what is water diffraction? Well, diffraction can be defined as the behavior of a wave when it encounters an obstacle and causes a wave to bend around the obstacle and make patterns of strong and weak waves radiating out beyond the obstacle. It's diffraction also not only happens in water wave, of course, it also happens in light waves, sound waves, and air. But those three, we can't really see it with our eyes because they're just not visible. The wavelengths are too tiny compared to water. But water, however, it's very common in nature. Water covers at least half of Earth, more than half of Earth. So I mean, it's really helpful for artists to know how diffraction works because most of the time when we go out to plein or trying to paint a piece with environments, most likely we'll run into water, and rarely does water sit still. So when there's movement in the water, when there's wind, diffraction will be there. So I have a few images here to show you guys how diffraction will look like once it's hitting coming through a slit or hitting an obstacle, or even caused by a woman walking in the water or just a droplet dropping down from the leaf. And there are length differences. Longer wavelengths will be more obvious, but smaller ones are not as obvious. So how does diffraction work? Well, diffraction are very simple actually, but often overlooked. Um, it's basically it hits an obstacle and the wave will bend in the direction of where it hits, or where the obstacle is sitting. So let's say if Delilah is lying on the water on the left of this picture right here, and the water waves are coming from bottom to the top. Once it hits Delilah's head, I mean Delilah, and then it will turn to top left, and not to the right or bounce back. Most people think that diffraction works like this image right here, where the wave goes straight through the slit, well, or just past through, like nothing happens beyond the area that are blocked, which are not true because the wave will bend, and it will, like sound waves, it will travel so we can hear echo. Um, so how do we paint diffraction, water diffraction in general? Well, one way to do it, well, you can't really make it out of your head because water is a really irregular, it's hard to imagine it out of your head. But what you can do is you can set up your own references. You can fill up your bathtub with water and let the water running, and you can place obstacles, or just stuff on the surface of the water, and observe how diffraction works and take pictures of it. Another way is that you can look at it as draperies. I think that draperies are very similar to, well, the way it looks are very similar to the effect that diffraction causes. It's basically just a rise and fall of tone and volume, depending on where, and depending on where the light source is at. So here are some pictures of some successful ones and unsuccessful ones. Um, so that's change. It's kind of small to see, but uh, so let's begin with this one. Um, in this picture, as you can see, it looks fake, because the water comes right through. Like there's no change of direction at all. It looks like the ship is copy and paste onto the image. The real water effect will look like the water is bending towards us, towards the viewer, and not go straight through the ship. This one's very successful. As you can see, though, droplets dropping from the top to bottom, and there are multiple water diffraction occurring, so there are interferences. Um, but it's very realistic. Obviously, this painter observed really well. And this is a master painting from Hudson River School. It's very well observed. You can tell that the water is going from left to right, well, the far left to the bottom right. But once it hits the land here, it causes the wave to bend and ripple towards the viewer. So that is it. It's hope you guys know a bit more about diffraction now, and